Hi guys, this is the EdExcel GCSE Maths Paper 3 from the foundation tier, and it's from the November 2019 series. For question 1, we have to write down two factors of 12. Well, 1 times by 12 gives 12, 2 times by 6 gives 12, and 3 times by 4 gives 12. So we can choose any two numbers, for example 3 and 4. Question 2, we have to find 1/3 of 30. This is the same as multiplying 1/3 by 30. In other words, 30 divided by 3, that's 10. So we get 10. Question 3, we have to write 0.7 as a fraction. Well, we see that we have one digit after the decimal place, so the fraction will be out of 10. And then we look at this digit 7, so 0.7 is the same as 7/10. Question 4, here is a list of numbers. We have the numbers 7, 8, 15, 16, 18 and 22, and we have to write down the number from the list that is a multiple of 6. Well, we can see here 18 is a multiple of 6. For question 5, we have to change 4 kilometers into meters. To go from kilometers to meters, we would have to multiply by 1000, and to go from meters to kilometers, we would have to divide by 1000. So 4 times by 1000, that's 4000. So 4 kilometers is the same as 4000 meters. Question 6. Here is a grid of squares, and we have to write down the ratio of the number of shaded squares to the number of unshaded squares. Well, we'll see that 3 squares are shaded. The number of squares that are not shaded is 5, so the ratio is 3 to 5. Question 7. W is equal to 4u plus 3, and we have to find the value of w when u is equal to 8. So when u is equal to 8, w is equal to 4 times by 8 plus 3. 4 times by 8, that's equal to 32. We add on 3, so we get 34. Sorry, we get 35. For question number 8, here are the first 5 terms of an arithmetic sequence. We have to write down the next 2 terms of the sequence. Well, if you look at the difference between the 1 and the 3, that's plus 2. If you look at the difference between 3 and the 6, that's plus 3. If you look at the difference between the 6 and the 10, that's plus 4. The difference between the 10 and the 15, that's plus 5. So the next term, can you see that's going to be plus 6? So 15 plus 6, that's 21. And then 21 plus 7, that's equal to 28. So the next 2 terms of the sequence, we have 21 and 28. Now, for question number 9, Mrs. Brown asked each child in her class which pet they liked best. So we have our results shown here, and we have to complete the frequency table for this information. So what we see over here is we have to work out a tally and then the frequency. So far we've got 1 dog. We'll cross this out. We've got 1 rabbit, 1 cat, 1 dog, another dog, a hamster, a cat, a dog, a rabbit, a hamster, a cat, another cat, a dog, another dog, a cat, a dog, a rabbit, and another dog. And if we work out the frequency, we have 8, 3, 5 and 2. And now for the next part of the question, we have to draw a bar chart for this information. Well, here we have 10 squares, so this over here is 10, so halfway, that's 5, and here we get 0. So if we draw a bar chart, well, we have 8 for Doug, so we have 1, 2, 3, 4, 5, 6, 7, 8, and then 3 across like so. And then we have over here 3 for cat, so cat, that's going to be 3, and then we've got, so that was rabbit, which was 3, cat is 5, so there's cat, and we've also got 2 for hamster, so there's hamster. And now we need to label all these, so here we have dog, rabbit, cat, hamster. Write down the most popular pet, clearly that's dog. Question 10. On the diagram above, you have to draw a diameter of the circle. Well, the diameter goes from one point on the circumference to another point on the circumference, and it passes through the center of the circle. So this over here is our diameter. And now for part B, on the diagram below, we have to draw a segment of the circle and shade the segment. Well, a segment, first of all, we need to draw a chord which splits the circle into 2 parts, and then we shade either one, which indicates a segment. So for example, shading this, we have over here a segment. Question 11. Dylan buys 13 bicycles for 7 bicycle lights for £7.50 each, and he pays with 5 £20 notes. How much change should Dylan get? Well, to do this question, first of all, if he pays with 5 £20 notes, he's paying altogether with 5 times by 20, which is £100. And if he's buying 13 bicycle lights for £7.50, the cost for all these lights, so the cost is equal to 13 multiplied by £7.50, and if we work this out, 13 times 750, that's 97.5. So that's the total cost, and therefore the amount of change he will get, that's equal to 100 minus the £97.50, so he will get £2.50 change. And now for part B of the question, the normal price of a bicycle is £120. In a sale, there is 1/5 off the normal price of the bicycle. We have to work out the price of the bicycle in the sale. Well, if it's 1/5 off the normal price, the new price is 4/5 of this original amount. So the new price is 4/5 of the 120, so that's equal to 4/5 multiplied by 120. So here we have 4/5 times 120, which is 96. So the cost now is £96. Question number 12. Cornflakes are sold in 2 sizes of boxes. We've got small, and we get a weight of 450 grams in a small box, and for a large box we get a weight of 750 grams. Ray buys 3 small boxes of cornflakes and some large boxes of cornflakes. In total she buys 5,850 grams of cornflakes. We have to work out the number of large boxes of cornflakes Ray buys. Well, to do this question, we can add up all the weights together. In other words, if we're buying 3 small boxes of cornflakes, the weight of the small will be 3 times by 450, and then we don't know how many large boxes of cornflakes we're buying. but we'll just call it L for now, and the weight of that's 750. So we multiply those together, that tells us the total weight of the large cornflakes, and the total weight altogether of the small and the large, that's 5850. So 3 times by 450, that's 1350, and then we add on 750L, that's equal to 5850. And we need to solve this equation to find L, and L over here is the number of large boxes of cornflakes. So first of all we subtract off 1350 from both sides, and if we do that, we have 750L equals 4,500, and now if we divide both sides by 750, it turns out L is equal to 4,500 divided by 750, which is 6. So therefore, he buys 6 boxes of large cornflakes. Question 13. The stem and leaf diagram below gives information about the ages of people in a social club. And we've got over here a key 4 with a line, and then a 2 represents 42 years. We have to find the range of these ages. So the range over here, that's going to equal the biggest age, take away the smallest age. So we have over here 74 being the big age minus 31, which is the small age. Turns out here we get 43. So we've got 43 years, which is the age, which is the range of ages. Question 14. Here is a rectangle. It has dimensions 7 centimeters by 3 centimeters. Colby has to find the perimeter of this rectangle. He writes perimeter equals 7 times by 3. What mistake has he made? Clearly, he's worked out the area by multiplying 7 by 3. And now for part B of the question, we've got a triangle over here. It has dimensions x centimeters, x plus 7 centimeters, and x plus 8 centimeters. Iram solves a problem about this triangle to find the value of x. Her answer is x equals minus 2. We have to explain why Iram's answer must be wrong. Well, clearly length cannot be negative, and the reason for that here, we can't have a length of minus 2 centimeters. That will be totally incorrect. Question 15. There are 800 students at a school. Each student has either a school dinner or a packed lunch. 31% of the students have a packed lunch. 55% of the students are boys. 60% of the boys have school dinners. How many girls have packed lunches? You must show all your working. Well, for this question, I think the easiest way to approach this is to construct a two-way table. So, constructing the two-way table, we've got 2 types of categories. We've got gender, boys and girls, and we've also got the type of lunch, packed lunch or school dinner. Now, there's 800 students in the school altogether, so we have 800 here, so we've got 800 students at the school. 31% of the students have packed lunches. So the total number of those who have packed lunches is 31% of the 800. So 31%, that's 0.31. And if we multiply this by 800, we get 248. So we've got 248 students who have a packed lunch altogether. Okay? And 55% of the students are boys. So 55%, that's 0.55 times 800. That's 440. So we have 440 students who are boys. And we also have 60% of the boys who have school dinners. So 60% of this 440 have school dinners. So we multiply this by 0.6, so we get 264. So there's 264 boys who have a school dinners. And we need to work out how many girls have packed lunches. So for that question, girls who have packed lunches is this element box over here. So to work this out, well, 800 take away 248, that's 552. So we have 552 people in total who have a school dinner. 800 take away 440, you'd find that to be 360, so there's 360 girls. Then 440 take 264, that's 176, so there's 176 boys who have a packed lunch. 552 take away 264, you'd find this to be 288, so there's 288 girls who have a school dinner, and therefore the number of girls who have a packed lunch, 248 take away 176, that's 72. So there's 72 girls who have a packed lunch. So let's just write this down. We have 72. For question number 16, in a bag there are only red counters, blue counters, green counters and yellow counters. A counter is taken at random from the bag. The table shows the probabilities of getting a red counter or a yellow counter. And the probability of getting a red, that's 0.4. The probability of getting a yellow, that's 0.25. The ratio of the number of blue counters to the number of green counters is 3 to 4. We have to complete the table. Well, if the ratio here is 3 to 4, let's suppose the probability of selecting a blue is 3x, and the probability of a green is 4x, so this satisfies having the ratio 3 to 4. If we find out what x is, we can use that information to find out the number of green and the number of blue. So we know that probability adds up to 1. So we have 0.4, that's the probability of a red, plus 3x, that's the probability of a blue, plus 4x, that's the probability of a green, plus 0.25, that's the probability of a yellow. And all this is equal to 1. So if we tidy all this up, 7x plus 0.65, that's equal to 1. 7x, that's equal to 0.35, and if I divide through by 7, x is equal to 0.05. So 3 times by 0.05, that's equal to 0.15, and 0.05 times by 4, that's 0.2. So this here is our completed table. For question 17, we have to complete the table of values for y equals 4x minus 6. Well, we can use the table function on our calculator. So we type in our function 4x minus 6, so we have 4x minus 6. We're going in between minus 1 and 4. We're going up in ones. So here we have minus 10. And if we work out the rest of them, we have minus 6, minus 2, that's given 2, 6, and 10. And now for part B of the question, on the grid we have to draw the graph of y equals 4x minus 6 between minus 1 and 4. Well, when x is equal to minus 1, y is equal to minus 10. And then when x is equal to 4, y is equal to 10. So if I draw this graph over here, we have something looking like this. Okay. Question 18. We have to reflect shape P in the line y equals 3. Well, if we draw the line y equals 3, the line y equals 3 is this one over here. So this is the line y equals 3. And if we reflect this shape, we'll do it in green. This here is where the new shape lies. For question 19, we have to solve 4 lots of x minus 6 equals 44. Well, the first thing we can do is divide both sides by 4. Of course we can multiply out, but I choose to divide by 4 first. So we have x minus 6 equals 11, and then we add 6 to both sides. It turns out x is equal to 18. So x is equal to 18. For question 20, we've got a set of numbers 1 to 13. A is the set of numbers which are multiples of 3. B is a set of even numbers. We have to complete the Venn diagram. So multiples of 3 and even, that goes in this intersection point. So we have 6 and 12. Those are our multiples, so let's just cross them off. Multiples of 3, well, we have 3. 6 is already chosen. 9 is not chosen. And nothing else is a multiple of 3. Even numbers, well, we have the 2, 4. 6 is chosen. 8 is not chosen. 10 is not chosen. And that's it. And the rest of the numbers go outside. So we have 1, the 5, the 7, the 11, and the 13. Okay, so that's question 20 done. Now question 21. Franco buys a house for £146,500. He sells the house for £158,220. We have to calculate the percentage profit. Well, first of all, percentage profit. So percentage profit, that's equal to the change over the original multiplied by 100. So we have the change 158,220 minus 146,500 over the original 146,500. And if we multiply this by 100, if we work this out, we have 158,220 minus 146,500 over 146,500. And if we multiply this by 100, turns out we get 8%. So we have 8% as our percentage profit. Okay, so now for the next question, we have to expand and simplify x plus 5 lots of x minus 9. Well, x times by x, that's x squared. X times by minus 9, that's minus 9x. X times by, over here we've got 5 times by x, which is 5x. And 5 times by minus 9, that's minus 45. And if we tidy all this up, it turns out we get x squared minus 4x minus 45. For part B, we have to factorise fully 9x squared plus 6x. Well, in terms of numbers, a 3 is common to both. In terms of the x's, x is common to both, and you'll notice 3x times by 3x gives the 9x squared, and 3x times by 2 gives the 6x. Question 23 for part A, we have to work out 29 squared minus 4.6 over the square root of 35 minus 1.9 cubed, and we have to write down all the figures our calculator displays. So here we have 29 squared minus 4.6 over the square root of 35 minus 1.9 cubed. It turns out we get 157.668255. And now working this out to 4 significant figures, well, if we look at the fourth figure, that's this 6, the digit after it, which is this 6 over here, is greater than 5. So this 6 over here, we round up to the next digit, so we have 157.7 to 4 significant figures. Okay, so now for the next question. The scatter graph shows information about the marks of groups of students who got in a science test and a maths test. And for this question, we have Jamie got a mark of 34 in the science test, we have to use the scatter graph to find an estimate for Jamie's mark in the maths test. Well, here we have to first of all draw a line of best fit, and the line of best fit goes through as many points as possible. So if we look at this, we've got 1, 2, 3, 4 points below this line, and 1, 2, 3, 4, 5, 6. So we need to adjust this a bit. So perhaps something like that. So now we've got 1, 2, 3, 4, 1, 2, 3, 4. Okay, so something like that is a good line of best fit, I think. Actually, it could be moved down a bit. So if we move it down, because the idea is over here, we want to go through as many points as possible. So something like that. And now for the next part, so okay, so if you got a test score of 34, that's over here, and then if we go across, that's 40. So actually, we did that a bit wrong. So 34, that goes up to here, and then going across, we get 39 for the maths. So an estimate will be 39. Okay, so now for the next part of the question. The table gives information about the times taken in seconds by 18 students to run a race. So we see that over here, and we have to work out an estimate for the mean time, give your answer to 3 significant figures. First thing we need to do is find out the midpoints of each of these categories. So here we have 7.5, here we have 12.5, here we have 17.5, and here we have 22.5. We then work out the midpoint multiplied by the frequency. 1 times 7.5, that's 7.5. 12.5 multiplied by 2, that's 25. 17.5 multiplied by 7, that's 122.5. 22.5 times by 8, that's 180. We then work out the sum over here. So if we work out the sum, adding all these together, we get 335. And if we add all the frequencies, we get 18. Now why did we do that? Because the mean, that's equal to the sum of the midpoints times the frequencies divided by the sum of the frequencies. So we have over here 335 over 18. So if we work this out, 335 divided by 18, it turns out we get 18.6 to 3 significant figures. So we have 18.6 seconds. Okay. Now question 26, we have to write 37 centimeters cubed in millimeters. So to do this question, what we need to recognize over here, to go from centimeters to millimeters, we normally multiply by 10, and to go from millimeters to centimeters, we normally divide by 10. So to go from centimeters cubed to millimeters cubed, we multiply by 10 cubed. Millimeters cubed to centimeters cubed, we divide by 10 cubed. So we're converting 37 centimeters cubed into millimeters cubed, so we multiply 37 by 10 cubed, so 37 times by 1000, that's 37,000, as we see over here. Question 27. Nimmer was driving to a hotel. He looked at his sat-nav at 1:30, so we've got the time over here and the distance to the destination. Nimmer arrived at the hotel at 14:48. We have to work out the average speed of the car from 13:30 to 14:48. You must show all your working. Well, you can see over here from 1:30 to 14:48, that's 1 hour and 18 minutes. Okay, so that is 60 minutes, that's the 1 hour, plus 18 minutes, which is 78 minutes. Okay, now the formula we need to use in this question is speed equals distance over time. Now we know the distance at 65 miles, we know the time, but the time needs to be in hours, because if you look over here, the units are in miles per hour. So to go from, if we write this on, to go from minutes to hours, we divide by 60, hours to minutes we times by 60. So 78 divided by 60, let's just work this out, 78 divided by 60, that's equal to 1.3. So we have 1.3 hours. So therefore the average speed, that's equal to the distance, 65 miles, divided by the time, 1.3 hours. So 65 divided by 1.3, that's 50. So the average speed is 50 miles per hour. Okay, so let's just add this in. We've got 50 miles per hour. Question 28. For part A, we have to write 32460,000 in standard form. Well, for standard form, the number needs to be in the form a times by 10 to the power of n, where a is in between 1 and 10. So, if the decimal point is here, we need to move the decimal place 1, 2, 3, 4, 5, 6, 7 places to the left. So we have 3.246 times 10 to the 7, and now writing 4.96 times 10 to the minus 3 as an ordinary number. We have this 4.96, we need to move it 3 places to the right, so we have 1, 2, 3, so we have 0.00496. So we have 0.00496. For question 28 part C, ASMA was asked to compare the two following numbers. So we have A, which is equal to 6.212 times 10 to the 8, and B, which is equal to 4.73 times 10 to the 9. She says because the 6.212 is bigger than the 4.73 here, A is bigger than B. Is she correct? And give her a reason for her answer. Okay, well, clearly they're not correct, because 10 to the 8 is smaller than 10 to the 9. It's like saying 5 times by 10 and then 4 times by 100. 4 times by 100 is obviously bigger than 5 times by 10. And it's a similar thing over here. The number that 10 is raised to the power of is bigger in this case than in this case. Okay, so now for question 29, the diagram shows a regular pentagon and a parallelogram, and we have to work out the size of the angle marked X. Well, over here, we can find out what each interior angle is in the pentagon. So the interior angle, that's equal to 5 take away 2 times by 180 divided by 5. And if we work this out, we get 108. So what does this mean? Each of these angles is equal to 108. So we have 108 there, 108 here, 108 here, 108 here, and then 108 here. We want to work out X. Now if you look at this parallelogram, we should know that the opposite angles in a parallelogram are equal, and you can show you're working on the diagram, you'll still get the marks. So this angle over here is 117. Now we know that angles in a parallelogram add up to 360, so 360 take away 117 take away 117, that's equal to 126. So this angle here and this angle here add up to 126, so if I divide this by 2, we get 63. So this angle here is 63, that's this one here, and this angle also is 63 degrees. Opposite sides in a parallelogram are equal. So we can form an equation. We have x plus 63, so we have x plus 63, which is equal to 108, and if I subtract 63 from both sides, x is equal to 45. Okay. Now question 30, A is in the shape of a quarter of a circle of radius 15 centimeters, B is in the shape of a circle and the area of A is 9 times the area of B, we have to show that the radius of B is 2.5 centimeters. Well, this shape here is 9 times the area of this full circle here, and we can't use a area scale factor because they're not similar shapes. What we can do is, if we work out the area of A and the area of B, and if we assume that the radius is 2.5 centimeters, if we multiply this by 9 and if we get the area of A, we've shown that the radius of B is 2.5 centimeters. So first of all, the area of A, that's equal to, well, we've got a quarter circle. The area of a full circle is pi times by the radius squared. So we have pi times by 15 squared, and then we divide by 4 because we've got a quarter circle. So here we get 225 pi over 4 centimeters squared. The area of B, that's equal to, well, if we assume that we have a radius of 2.5 centimeters, let's just add this on. So if here we've got 2.5 centimeters, we have over here pi times by 2.5 squared, which is equal to 25 pi over 4 centimeters squared. And you'll notice over here, if I divide these two and get 9, then we've shown it, because then we've shown that A is 9 times the area of B. So the rest of the statements follow. So what we have over here is 225 pi over 4 divided by 25 pi over 4. Well, here those 4's cancel, the pi's cancel here. 225 divided by 25, that's 9. So therefore we can conclude that the radius of B is equal to 2.5 centimeters. Okay, so that's exactly what we wanted to show.